Hi, I'm Brian Keel, an economist with WSP, a consulting firm on the Broward Safety Action Plan. Today, we'll be reviewing the benefit cost analysis tool created for the Broward County Safety Action Plan. This benefit analysis tool, or BCA tool, is designed to help users in the county quickly sketch the benefits of a potential road safety project. With just a few assumptions around the project costs and crash data for the roadway in question, this tool will help you forecast the potential reduction in crashes for vehicles, cyclists, and pedestrians, and compare the monetized benefits of this reduction to the project costs. Let's get started. Before we view the tool, we'll go through just some of the parameters and some of the basics around how the tool is used. This tool is looking at the full cost of the project compared against the benefits from the reduction in crashes. Key outputs include a benefit cost ratio, the net present value of the benefits, and both of these in undiscounted and discounted terms. Most of the details here, assumptions, are coming from US DOT as well as Florida DOT guidance. The BCA tool has a few limitations that really relate to how it's used at a sketch level. This tool should only be used to get a preliminary understanding of the potential benefits that are limited to safety and operations and maintenance benefits, and should only be used for planning or project comparison purposes. Insights from the model are limited to the data available, as well as some of the assumptions in that model. Further analysis on benefits and costs outside this model will have an impact on the project's overall feasibility and societal benefit. The crash modification factors only consider crash mode, crash severity, location, such as the intersection or the main line, and the time of day, and does not consider the collision type or other contributing factors. Before using the tool, we'll need crash data to be downloaded from Signal 4 Analytics and sorted with the requisite data fields for crash mode, crash severity, location, again at the intersection or at a main line, and then time of day. We'll also need to estimate the construction costs and the years of expenditure for the project that's being analyzed. These are our basic steps that we'll then view after this presentation. We'll first input that crash data that we've collected. We'll confirm the project start year and construction costs, confirm our crash costs, select the countermeasures that will be used to analyze, and then we'll be reviewing the results. This is the table of contents for our model. You can navigate the model with the spreadsheet tabs located at the bottom of your screen and find a description of each tab here. The orange and teal tabs will be our most used tabs, and the orange tabs will be where we input the information that's coming from your project, while the BCA summary in teal will show us our key outputs once the required information is input. Our countermeasures tab in green is the master list of safety improvements we currently have at our disposal, listing a variety of countermeasures studied as part of the Broward Safety Action Plan. As you'll see, there'll be room to add more at your discretion, and we'll go out over how to do that at the end of this how-to video. To help demonstrate the flow of the tool, we're going to use a hypothetical project to fill in the user inputs and see what our benefit cost analysis looks like at the end. So the first step will be to input our crash data. So for our hypothetical project, a corridor safety improvement project, we have pulled the crash data, again, all hypothetical, and we have organized it over 5 years of crash data to then fill in the requisite crash data. So we pedestrian incidents here at the intersection, main line, then it's also split by day and night. So once you've taken that crash data that you've gotten from Signal 4 Analytics, we'll then go into our project input tab here. Here we have cells that are colored green and yellow. Green cells are assumptions or values set in the model. These are default assumptions that should only be changed based on updated information or circumstances of your project that require a change. The yellow cells will be the cells you relay your base project information to complete the BCA. First, define the construction start year, the period of design and construction, and the project opening year. If you would like to front load your project costs into 1 year, mark the period as 1 here, and all costs will be included in the start year. For our hypothetical project, we'll be selecting 2026 as our start year. We'll then assume 2 years of construction with a project opening date of 2028. Next, select the countermeasures your project includes via the drop-down menus down here. You have up to 10 slots, and your selected countermeasures will show the corresponding crash modification factor used to estimate the reduction in crashes. The type of crash applicable is defined by the severity, group or mode, time of day, and location. For our corridor project, we're assuming 5 countermeasures to improve safety on the corridor and the main line. Our first countermeasure is going to be a raised crosswalk. Our second countermeasure is going to be a pedestrian, or rather a leading pedestrian interval. Our third countermeasure is going to be a protected left turn. Our fourth countermeasure will be a, I think we already have a pedestrian hybrid beacon. Apologies. And then finally, our project corridor is also going to have a protected bike lane. Next, we're going to select the number of years that we have our crash data on. We've set this as 5, as that's typically standard, but this can be edited based on however many years you used for your crash summary data. Finally, we're going to define our total capital and O&M costs. The total right-of-way costs and construction costs should be input here. If known, the preliminary engineering costs and construction engineering costs, they can be then put in here. Otherwise, the percentages shown here will be used to define those engineering costs. They've been set to 10%, but can be added based on your experience with real costs in your projects. For our project, we'll assume construction costs at 25 million. So we'll put that here, and we'll also assume 0 right-of-way costs. Similarly, the O&M costs can be put manually if known down here, or use a percentage to set the costs. The 1% input here for both no build and build indicates there's no net O&M costs. However, if you expect a new project to either raise your O&M costs or lower them, you should change the percentages correspondingly. For our project, we're adding new infrastructure that may cost added, or rather would have higher operations and maintenance costs. We're also replacing older, more costly infrastructure. So we'll assume that the O&M is the same by keeping the percentages the same here. And again, these percentages are based on an annual percentage of your construction costs. Note that the model also includes an operational cost per crash response. This is how we can show a slight operational benefit based on the number of crashes that we are mitigating through our crash modification factors. Once all these are input, we're going to give the numbers a final check to make sure everything's filled in. And then our BCA should be complete. We can then go to our BCA summary tabs and look at some of our main outputs here. Our total benefits, both in undiscounted and discounted terms, our total costs, and then things to compare that to have a proper analysis like the benefit cost ratio, internal rate of return, and the payback period. When thinking about whether a project would be cost effective, we typically think about a project that, when discounted, has a benefit cost ratio above 1. And this project here has a benefit cost ratio, our hypothetical project has a benefit cost ratio of 1.22. Again, as mentioned, if you have countermeasures with a known the crash modification factor, we can then input them into our table here, which will then make that included on the drop-down menus on the project inputs tabs. If you need to add more lines, you can simply right-click this row here and then add a row or insert a row here. But when you do that, you would also then need to include that within your drop-down menus. So in able to include that new countermeasure that you're adding, we would select each of our countermeasures. We'd then go to data, we'd go to data validation, and then we'd update this formula here to include the added lines. Again, as you'll see, we already have 4 blank lines for you to add countermeasures. So you shouldn't have to do this unless you have more than 4 new countermeasures that you're trying to include. That wraps up this tutorial, and thanks for using the benefit cost analysis tool.